Hello everyone, welcome to my channel. Now in this video I am going to discuss the topic Young's double slit experiment, and this experiment is based on the phenomena of interference. Okay, now interference is like if you have two coherent sources. Okay, now what do you mean by coherent source? Now two sources are said to be coherent if they are sending light wave either at constant phase difference or zero phase difference. That is, the phase difference, they should have the same phase, or if at all there is a phase difference, the phase difference should be a constant. Now such sources are called coherent sources. Okay, now if light from two coherent sources are made to be incident on a screen, then on the screen you will get alternate dark bands and bright bands. So the interference phenomena, it says that in the screen you are getting this dark and bright bands, that is, the energy is redistributed. Okay, you are sending two light waves from two sources, that means you are getting energy from two sources, but on the screen you are getting the energy is redistributed, means at some points the energy is maximum where you are getting maxima, and at some point the energy is minimum and you are getting minima, this darkness. So alternate bright and dark bands. So interference is defined as the phenomena of superposition of light waves from two coherent sources leading to redistribution of energy. Okay, so this is interference. Now this entire Young's double slit experiment is based on the phenomena of interference, constructive interference and destructive interference. So constructive interference corresponds to maximum intensity, destructive interference corresponds to minimum intensity. Okay, so now let's proceed with the experiment. So in an interference, the requirement of the source is you need to have two sources, and the two sources need to be coherent. Okay, now it is impossible to have two independent coherent sources. Okay, like suppose if you have two bulbs. Okay, now suppose these are two bulbs with two filament bulbs. Okay, and even if I switch on the two bulbs at the same instant, see these bulbs, they are emitting light because of transition of electrons from higher orbit to low orbits. Okay, and that energy is acquired by the electricity. Okay, but this transition of electrons, it is a random process. Electrons will go to different states randomly, and then they will come to the ground state, that also randomly. So that means the light which is emitted from these two sources can never be coherent. Okay, so therefore two independent sources can never be coherent. Okay, this question has been asked in examination also, that like why can't we have two independent sources producing an interference pattern, a sustained interference pattern. Now for sustained interference pattern, the sources must be coherent. Okay, so two independent sources can never be coherent. So but the requirement for interference is you need to have two sources. Okay, so how will you produce that condition, or how will you satisfy that condition? Like suppose you have two slits, S1 and S2. These are two slits, and this is source S. Okay, so light, it is coming out from this source. Now these two slits, the light which is coming out from these two slits, now these slits will act as source. Okay, and now this light is made to be incident on the screen. This is the screen, and suppose some point P, we are observing the intensity at this point P. Okay, so light from S1 is going to P, light from S2 is also going to P. Okay, now let's say the slits are separated by distance small d. The two slits are separated by distance small d, and the screen is at distance capital D. Okay, this point P, this is the center of the screen. This point P is at distance x from the center of the screen. Okay, now one ray is traveling from S1 to P, another ray is traveling from S2 to P. So what will be the path difference of the two rays? It will be path difference, it will be S2P minus S1P. Okay, this is the path difference. One ray is traveling from S2 to P, another ray is traveling from S1 to P. So path difference of the two rays traveling going from S1 to P and S2 to P is this is the path difference. Okay, so now what is, see if I see this triangle, Then if I use Pythagoras theorem, I get S1p square is equal to d square. See, this is d by 2. This distance between the two slit is d. This is the midpoint. So this distance is d by 2. This distance is also d by 2. Small d by 2. This is d by 2. Separation between the slits is d. So this is d square. This entire thing is x. So this distance will be, I am taking this triangle. Okay. So for this triangle, this is S1p square is equal to d square plus, what is this distance? This entire thing is x. So this distance will be x minus d by 2. So plus x minus d by 2 square. Okay. Now similarly, what will be S2p square? S2p square will be d square plus, now I need to take this triangle, isn't it? So this is d, this is x, center to this point is x, and this is d by 2. So it is x plus d by 2 whole square. Okay. So now if you subtract these two equations, what do you get? S2p square minus S1p square is equal to, this term cancels out. Okay. Now if you simplify all these things, you will get 2xd. So I have S2p square minus S1p square is equal to 2xd. Now S2p minus S1p can be written as S2p minus S1p, S2p square minus S1p square. This is written as S2p minus S1p, S2p plus S1p, that is equal to 2xd. Okay. Achha. Now normally this screen will not be very far distance, it will not be at very far distance from the plane of the slits, and this P point will not be at very much large distance from the center. Okay. So that means this distance S2P and S1P is almost equal to this distance, because this is not very far off and this point is also not very far from the center of the screen. So that means the approximation is S2P is approximately equal to S1P is approximately equal to this separation D. Okay. Now S2P minus, so this is S2P minus S1P, this is S2P plus S1P. Achha, I will not substitute here S2P minus S1P, because if I substitute this condition over here, this will be 0, but I need, this is the path difference, I need to find the value of this path difference. Okay. So this is the path difference and this is D and this is also D. So D plus D will become twice D, that is equal to 2xd. So the path difference becomes S2P minus S1P is equal to 2xd divided by 2d, this is d plus d. Okay. So this 2 cancels out. So we have xd by d. This is the path difference. Okay. So we have the result for the path difference as S2P minus S1P is equal to xd by d. This is the result of the path difference. Now for maximum intensity, we have already seen that this path difference S2P minus S1P, this is equal to n lambda. If the path difference is an integral multiple of lambda, where n is equal to 0, 1, 2, 3, then we will get maximum intensity, that is constructive interference. So that means if I equate these two equations, I get n lambda is equal to xd by d, or x is equal to n lambda d by d. So for n equal to 0, what is this x? S is the distance from the center. So for n equal to 0, x is equal to 0. That means at the center of the screen, we will get a maxima. Okay. Then see, for n equal to 1, we will get x equal to lambda d by d, x equal to 2 lambda d by d, x is equal to 3 lambda d by d. So at such distances, you will get a maximum intensity. Okay. So this is the condition for maximum intensity. At this distances from the center of the screen, you will get maximum intensity. Now let us see what happens for minimum intensity. For minimum intensity, we have the path difference is equal to n plus half into lambda. This is the condition for path difference. So we have n plus half into lambda is equal to x d by d. So this gives x is equal to n plus half lambda d by d. Okay, so at see now even if I substitute n equal to 0, x is not equal to 0. So that means center we will not get a minimum intensity. Center you are getting a maximum intensity. Okay. Now this expression can also be written like twice n plus 1 lambda d by twice d. Okay. Either you write like this or you can write like this. Okay. So for these are the locations at which you will get destructive interference. So for constructive interference, or maxima, constructive interference or maxima, that is position of maximum intensity, we are getting x is equal to n lambda d by d, and for destructive interference we are getting x is equal to twice n plus 1 lambda d by twice d. Okay. So this is position of maxima, this is position of minima. Okay. Now based on this, so the pattern, interference pattern will be like this. Interference pattern on the screen will be like this is bright band, then dark band, bright, dark, bright. So alternate dark and bright bands. Okay. Now let us, so this is, suppose this is central position. This is the central position, so this is bright band, bright, dark, alternate, dark and bright bands we are getting. Okay. Now let us calculate the width of bright bands and similarly the width of dark bands. Okay. So now see, this is the position of maximum intensity. So width of the bright band, if beta is the width of the bright band, okay, beta will be equal to xn minus xn minus 1, that is n bright band minus n minus 1 bright band. So if you substitute the values, you will see this is equal to lambda d by d. Okay. Now similarly for this bright band width, it is the same value xn minus 1. So xn will be twice n plus 1 lambda d by 2d. xn minus 1 will be 2 n minus 1 plus 1 lambda d by twice d. Now if you simplify this, again this value is also lambda d by d. So it shows that this both the results are same. So this result shows that the width of the bright band is equal to the width of the dark band. So we have the result beta is equal to lambda d by d. Okay. So this is the width of the bands for bright band as well as for dark bands. Okay. Now this relation says that this beta is proportional to lambda. Okay. Now see this experiment, suppose it is conducted in air, and then without disturbing the setup, this entire setup is immersed in a liquid of refractive index mu. Okay. Now in the liquid, this wavelength lambda will become lambda by mu. Okay. Why? Because wavelength is inversely proportional to the refractive index, or refractive index is inversely proportional to wavelength. So that relation lambda will be replaced by lambda by mu. So this is in case this setup is immersed in a liquid. So in that case, this beta will be, if lambda is replaced by lambda by mu, that means beta will be replaced by beta by mu. So beta in a medium, beta, that is fringe width in a medium, is equal to fringe width in air divided by refractive index of the same medium. Okay. So this is regarding if the instrument is immersed in water, then what will happen to the fringe width. Okay. Then what is this angular separation? Like suppose this this is the bright fringe. Now this angle formed by the fringe at the plane of the slit, this angle theta is called angular separation. Okay. Now as you can see, this is beta. Okay. Now if you consider this as arc beta, this radius as d, d is the separation between the slits and the screen. So this distance is d. So angle equal to arc length by radius. So I have theta is equal to beta by d. Okay, but what is this beta? Beta is lambda d by t. So divide by d. So this d cancels out. So that means theta is equal to lambda by d. So this is the expression for angular separation. Now usually this angle will be very small. Now for small angle this theta can be replaced by sin theta. So we have sin theta is equal to lambda by d, or theta is equal to sin inverse lambda by d. So this is the expression for angular separation. So these are the few concepts related to the Young's double slit experiment. I hope these things are helpful for you. So my best wishes. Good luck.